Hey guys, welcome back. So this is my 10,000 watt load bank. I'm sure most of you have seen this. It is used in pretty much every video. And it is actually a fairly recent ad. I've only had it maybe 3 years. And before that, the load testing was just with portable space heaters, which worked fine. The issue is sometimes I needed 5 or 6 space heaters to test the machine properly. And this load bank replaced all that. At least it did. Recently I've been fixing a lot of standby generators, and they require often more than a 10,000 watt load to test properly. Some of them up to 20,000 watts. So the ideal solution would be just to replace this with something larger. But these load banks, they're pretty expensive, and they're actually hard to come by, at least on the secondary market. So in the interim, I found a solution for about $200, which is going to double our capability from 10,000 watts all the way up to 20. And the solution is more space heaters, but not like the ones I've been using. These are actually 240 volt, 5,000 watts each. So together, this is an additional 10,000 watts, which is going to double the capability to 20,000 between the load bank and the space heaters. Now, getting the space heaters installed on this cart, I think, will be the easy part. The issue is most generators only have one high wattage output. So, I could get away with connecting a 10,000 watt load and several 1,500 watt loads. But if I now have a 10,000 watt load and two 5,000 watt loads, then likely I'm only going to have one place to wire this in to the generator. So it's going to open a bit of a can of worms as far as how we do the wiring and how we make this all work. But I think we can make it work. So I'm going to start simple. We're going to get the new space heaters mounted to the cart. We'll do the wiring, and then of course we'll try it out. And the first decision we need to make is where exactly do we want to put those space heaters? Initially I was thinking it would be good to have them as part of the cart so we can just roll this whole thing out as one unit. And stacking them may not be a bad idea, but after measuring it up, the stack is actually a little bit too tall, so it's not going to fit. Another way we could go is just putting them side by side, and that should fit. The only downside is we're going to need a pretty big gap between them for the wiring, and likely they're going to hang off the edge and heat up the rail on the table. Not to mention 10,000 watts of heat coming right at me, which in the winter might be welcome. The rest of the year, not so much. So I'm thinking instead we just mount one heater on the left facing out and one on the right facing out. And that will make it so that the bottom shelf might still be usable, and we should hopefully have enough air gap here for the fresh air intake. So let's clear the cart. I want to flip it over. We'll size things up and go from there. So I'm thinking something like that, and the same on the other side. And I guess the only downside is that the wiring, at least for the unit on the left, is going to exit the side right there. So we're going to have to wrap it around, but you can see there's plenty of gap, and these are going to be lifted up, so plenty of airflow into the units. I think this will be fine, positioned about in this area, just secured to the bottom of the table. We can do that on both sides. So before we do that, I think we should run the wires. We'll connect the wires at least to the unit. We'll get them mounted up and then figure out how we're going to tie everything together. As far as the wiring goes, the instructions, I wouldn't say are super detailed, but from what I can see, wire needs to go in on the side. And we have a bunch of screws going around. I think this bottom cap will lift off, and then we'll have access to what we need. And yeah, not a whole lot to it. So we need 3 wires in total, 2 live wires for leg 1 and leg 2, and then the ground wire. So I actually have 4-wire generator cord that's 10 gauge, which would be perfect for something like this. I do also have some 3-wire 10 gauge, which I might use. The wire colors aren't going to be quite right, so we're going to have to fix that. But the thought is, you know, that is extra wire from generator cords that didn't have the right amount of conductors. So I really can't use them on a generator, but something like this only needs 3 wires, and that would be perfect. And I think we're going to use the larger of the 2 knockouts. And we're going to strip back the white and the black wires and just add some ferrules. Now in this case, the white wire is going to be one of the live wires. You know, normally white is neutral, so we're going to have to color it red just so if someone else is working on it besides me, they actually have a clue, you know, as to what's going on. And for the green, we're just going to add an eyelet. And we're going to make this white wire red. It kind of looks a little orange. See if we can turn that around. Yeah, it looks like it's double-sided sticky tape on there, which is kind of too bad because if you use the side to come in here, you know, it's misaligned. It should be shifted over a bit. And on the other heater, I was actually thinking about just drilling out on this side so that we have both wires exiting toward the back of the cart, and then we can move this over as well. But since it's taped down, likely that's not going to happen. So not a big deal. We do have strain relief right there. Don't think that's going to do a whole lot. So we'll get the black wire in, as well as the red. And then finally the ground. And there is torque spec on this. Good and tight works, but if you want to do it the way the sticker says on the other side, then we should go to 35 inch-pounds, which is quite a bit. I think we're just about there. Yep, that one is done. And we'll do the same on the other side. And the bit broke, so we're going to call that one good enough. And the last one, we'll torque that as well. Actually, I found another bit. Let's finish this one up. So we've got one done, one to go, pretty much the exact same process. So I'm not going to record that one. We're just going to skip ahead and get these installed to the cart. And just like the other side, we've wired this one up and it is good to go. The only difference here is that I did run the wire in from the opposite side. So that way, when we get these installed on the cart, both the wires will exit toward the back. So let's get this off the cart. We'll flip the cart upside down and mount both the heaters. So this table, it is exactly 2 feet wide, and we're going to center the heater right in the middle, or at least close to it, which is right there. And then we want to have it set back just about that far. It'll be just enough room so that we can install the knob, and I've preset this to the correct length. So what I'm going to do is use this center mark, and we're going to center up this bracket on that mark. Now, I am noticing, I thought we were a little bit off center compared to the legs. I guess technically, these legs could have been screwed in a little bit off center. But it doesn't have to be perfect. I think right there should give us what we need. So I'm just going to mark this one. We'll pre-drill it, attach a screw, and then we'll do the other two. And I just marked with a piece of tape, how deep I want to go. If we go as deep as the screw, it's only going to leave a tiny bit before we poke through. So likely I'm going to use a couple washers just as a safety margin so that we don't cause damage to the top. And yeah, we're a little bit further back than we want it to be, which is fine. Further forward would be a bigger problem because then we would not be able to get the fasteners in that we need. Yeah, everything really fit in there quite well. A lot better than I kind of imagined. So right now we do have 20,000 watts of load safely on this cart. And I think the big question is, how are we going to take advantage of it? And initially, I was thinking about just cutting the plug off the load bank. We have a 50 amp plug right here. And once that's removed, we could actually wire in the load bank and these two 5,000 watt space heaters right into a breaker panel. And then the breaker panel would be fed from the generator we're testing. So in theory, that all sounds good, but in practice, we're going to have a problem because to hook up to a standby, you need to hardwire it. And to test a portable, you need a plug. So the solution to that would be a manual transfer switch or potentially an interlock, where we could feed two different inputs of power, and the interlock and the transfer switch would ensure that only one comes into the panel at any time. You can't have a situation where you're feeding power in through one and the other one is live. So that was kind of the direction I was leaning. And then I realized, I think I'm just overcomplicating things because most portables, the load bank is all we need. This is 10,000 watts, and actually the largest plug on a portable is 50 amps or 12,000 watts. So even if we have a larger portable, like say 17,500 watts, we can only test it to 12,000 watts with a single wire. So I think what I'm leaning towards is just leaving the plug on the load bank. We'll use this for testing portables. And the only time we're really going to need access to the full 20,000 watts is when we test some of the larger standby machines. And for that, we will have a breaker panel. We'll have 2-gauge wire going into it, which will be hardwired to the generator. That panel will be feeding these two 5,000 watt space heaters. And then we're going to add a 50 amp output from the panel that we can plug the load bank into. And when we do that, we'll then have access to the full 20,000 watts for testing standby generators. And with that new understanding in mind, I need to make a trip to the store and get a sub panel rated for at least 100 amps. We made it back from the store with pretty much everything that I think we're going to need to finish this up. Starting with the circuit breakers and the star of the show, this panel right here that's rated for 125 amps, which translates into 30,000 watts. So that should be more than enough for our needs. Now, the big decision here is kind of where to put it on the cart. And originally, I was kind of thinking the top right, or maybe the top left. But the panel, probably not a good idea to do that because the largest punch outs are actually on the top, and we might need that for the 2-gauge cord for the incoming power. So that brings us to either the bottom left or bottom right, and the left side of the panel actually has no knockouts at all. So if we put that panel in the bottom right, then the install is going to be a little bit messy. So from the process of elimination, bottom left, I think, is the winner. And I wouldn't say the bottom left is perfect either. We do run into some interference with this cord. And granted, it is flexible, but I think I might cheat a little and nudge the box over so that it overhangs a bit kind of off the side. So, easy enough to install. We're going to install 2 through bolts right here, which will go through those holes. The center hole, though, that's a problem on the top. We don't have anything to tie that into, so instead, I'm going to drill another hole kind of in this area, and when we mount it up, we'll have 3 of the 4 corners secured, which I think will be good enough for our purpose. So we're going to make the hole on the bottom approximately the same distance from the side of the box. As far as the height, don't know if it matters too much in this case. Where this existing one is, it's actually pretty good. So I'm thinking we should drill right about there. I think that'll do. Just going to be using these 1/4-inch bolts to secure everything, and it seems to fit in there pretty well. So let's find on the cart where we need to drill. And actually, I think we should mark and drill that one first because there's actually a lip and, of course, a very small area that we have to hit. Whereas here, we have a lot of fudge factor. So, yeah, let's mark and drill that bottom right hole, and then we can fill in the rest. Slight miscalculation here. So this shelf is blocking the backside of this hole I just drilled. So potentially I could put a nutsert in there, but I'm not sure I have the correct part. Otherwise we could actually drill another hole in the breaker panel box a little bit higher. But let me look around first, see if I have anything that'll work with a hole that isn't a through hole. So I looked around, and this is the largest self-tapper I have, and it's too small. I do have some drywall screws, but they're expecting a wall thickness, whereas this is pretty thin. The only other thing I have that could work is this right here, which I'm not sure if it's a sheet metal screw or a wood screw, but that likely would bite good enough to work. And given we have a through bolt with a nut on the top and the side, likely this would be good enough. But I'm thinking, you know what, let's just drill another hole. So I'm going to bolt the box on with the 2 bolt holes we have, and then we'll just drill a new one right there and secure that with a nut on the back side. Yeah, and actually, we really don't need that bolt down there. The 2 that we have seems to hold it pretty well. So I'm not going to drill another through hole, but I think I will try driving this one in just as insurance. So now that the box is nice and secure, we can get everything wired in. So I did spend a few minutes off camera just stripping back these wires for the 2 space heaters. And I also had 2 cords already made up with plug ends. So the plug ends have been removed, and these will be installed as well on the cart. One for the load bank and one for the kilowatt and any accessories we want to run. So we're going to get this one wired up to the breaker in the bottom left. It's going to be a 30 amp breaker for one of the space heaters. The other space heater is going to be connected here in the top right, coming in from the top. The convenience outlet will be fed from the bottom right, and the top left will be the 50 amp output for the load bank. So we're going to start here with the green wire. Cut that one approximately to size. And all these will have ferrules added and installed in place. And now we'll connect up the other space heater. This one we're going to do from the top and just kind of loop it around. Like that. I'm going to throw a little disclaimer in here. I'm not an electrician, so, what I'm doing here, is it to code? Probably not. This is an indoor box that I'm using outdoors, but it's never going to get wet. And I'm sure there's some other violations as well. I almost forgot. I did not color the wire on the other side red. So we'll be sure to backtrack on that and color this one red as well. All right, so that issue's been corrected, and at this point, both the space heaters are wired in, so those are good to go. Next, we're going to do the outlet for the load bank. So I've taken the cover off of it and just trying to decide where to mount it. So there are two holes right here on the metal plate that I think we can just drive some self-tappers through. There's a couple more at the top, but there's no metal bushing. So we could add a couple screws there. I guess my concern is I might crack the plastic if I'm not careful. So let's start with the bottom two, see what kind of support that gives us, and if need be, we'll add a couple more to the top. Yeah, I guess the only downside is the wires are kind of blocking it, at least leg 1 and leg 2, so I think we need to free those and just kind of move them off to the side. And let's just try it out real quick. Make sure those 2 screws are enough. Now, ideally, I would have done it like that. But based on kind of the wiring, it can only come out one way. Fuse box is down below. So instead, we have to plug it in with the cord kind of going up, which isn't the end of the world. But it seems to go in there well. And it is attached pretty solid. So I think we're fine just with those 2 self-tappers. And for this setup, a very similar thing, although we have 4 wires, and they are the proper color. So the red and black go into that breaker, and the green and the white are going to be tied in to this bus bar. So let's start with that. And my wire strippers, they're not going to strip this wire. The gauge is too thick, so you can use a razor blade, just be careful. And if you do it right, a lot of times I think it works better. So you can kind of feel as soon as you're through the insulation and stop, before you've cut any strands of wire. And we are getting there, slowly but surely. So this is a very long and tedious process. Likely I'm going to skip a bunch of this in the video. But we only have one more left as far as the outputs go. And that is going to be the 20 amp output. We're going to send one leg to this outlet and the other leg to this outlet. So we'll have 2 120 volt outputs at 20 amps each for a total of 40 amps at 120 volts. But that is going to be mounted on the front in the bottom left corner. And I think we're going to do the same thing here, just a few self-tappers to hold this in place, and then we can run the cord over to the box. Although, as I'm holding it here, I'm guessing this might be a better way to do it, so that way the cord isn't quite as strained. Well, it's a few days later, and I think we have what we need to finish up this project. So this is actually a 4-gauge cord. I ended up changing up the order because 2-gauge really isn't needed for this setup. As it stands right now, we can only pull about 84 amps, and the 2-gauge would have been future-proofing things a bit, being that the box itself can handle 125 amps. But in our case, I wanted to go with something a little bit smaller in diameter. Even so, the 4-gauge, it is pretty beefy. But being that it's copper and the insulation's rated at 90 degrees Celsius, this should be more than adequate for the current setup. So I've already stripped back what's going to be attached to the generator side. We still need to add the ferrules to it. But let's get it connected to the box first, and then we'll finalize the installation. And the first thing we need to do here is strip back this outer sleeve. So I did pick up the proper tool to do that. This wire is not cheap, and doing it the way I normally do with the razor blade, although it usually works, sometimes it doesn't. And, at the price that this stuff is at, I think it's about $10 a foot, you'd hate to ruin it. So we are now through the sleeve, and if we slide the tool out, it should also cut it, or at least score it, lengthwise. And then we should be able to peel it off, kind of like peeling an orange. And we're probably going to have to do that one more time, because as it is right now, that is not enough to get it installed in the box. And I think I'm going to run the cord in through the side here. It would be a cleaner install from the top, but given that the cord's going to run on the ground, if we do that from the top, it's going to put a lot of strain on the cord as it bends 180 degrees down to the ground, whereas the side might make it a little bit harder to get it clean in the box, but at least it only has to bend a little bit as it goes down to the ground. And it's a nice straight shot to leg 1 and leg 2. We just need to cut it to size. But I do want to add something. At least I'm thinking about adding it. I want to add a meter that can actually measure the amps, the watts, the volts, and the hertz on the total current flowing through this box. So the meter I got does have a current transformer. The issue is it only has one. So if we install it here, we're only going to measure half the load. Technically, you could loop this wire through twice, and then it would double the load. And if you have a balanced load, that would be okay. But in our case, we do have a couple 120 volt outputs on the front. So to be most accurate, we'd either have two current transformers, or you could run both wires through it. The problem is you can't run it in the same direction because these are 180 degrees out, meaning when one's positive, the other one's negative. And the way you need to do this is to run one wire through it one way and the other wire through it the other way. So that'll solve that problem, but it's going to potentially make a little bit of a mess inside the box. Yeah, it definitely makes it a bit of a mess, but not too bad, actually. So the red wire is still a straight shot, and it's the black wire that's looping in on itself. But I think that'll be good enough so we can make some cuts, add the ferrules, and secure those wires. So I'm going to keep these wires on the longer side, just in case we have to redo something in the future. Should probably tighten that up a little. Anyway, that connection's on. And then we'll do the final one here, which I think I'm going to leave the wire length where it is. Again, I want to have a little extra just in case we have to redo something in the future. And that one's a little long, which is fine. We can trim that. All right, those are snugged up. And the current transformer seems to be pretty well situated. Now, I haven't quite figured out yet how I want to extend these wires. These are pretty tiny wires, and the gauge I'm going to use is up on top of the load bank, or at least it will be. I also wired in some auxiliary power, 120 volts with a 2 amp fuse, which is what will power that gauge. So we'll circle back to that later. For now, let's just finish up the main wiring. And for that, we have one connection here for the neutral. And because I'm using this as the main breaker panel, we do have the grounds and the neutrals on one bus bar, which is fine. That's how we want it. But I do have to add the grounding screw just to connect this bus bar physically to the box itself. And as far as the ground goes, I haven't quite figured out where this is supposed to go because there is no lug for it. And this gauge is much too thick for one of these on the bus bar. So, potentially I might need to connect it there, which is where that bond is going to occur between this bus bar and the panel. Otherwise, I could potentially connect it right to the box, but that also doesn't seem great. But without any other provisions, I'm not really sure what the intention was with the manufacturer, so I might have to research that a little bit. But for now, let's get the neutral connected. All right, that's good enough for now. And yeah, the ground, I'm going to have to give this one some thought. I think either way, probably going to have to add an eyelet to this, and we could connect it right there on the bus bar with this screw that connects this bus bar to the panel. It may also have like a lug that we could also connect there. So let me look around for that first. So it might be kind of hard to see, but this is where that grounding screw goes. So that connects the bus bar to the actual metal here on the box. And what I was thinking was potentially adding a lug to that, but there is raised plastic on the backside, so I don't think that will sit in there properly. Let's try it real quick. And no, it's not going to. So we either have to modify the plastic or come up with a different plan. I think the answer here is just to connect this the way it was intended. So now this bus bar is connected to the box. And if this was a main panel, you could have additional bus bars for ground. And you don't have to run a dedicated wire to it. Just screwing that bus bar into the box is enough to pick up that ground. So I'm thinking we're going to do the same for the ground wire. We're just going to connect it right to the box. And then between that connection of the ground wire to the box and this connection right here of the box to the bus bar, we should be covered. So again, I remind everyone, I am not an electrician, so don't do what I do. I'm going to leave it to the electricians to comment on where this should be. But the fact is, this wire will only go in a large lug, and we only have the 3 lugs. So that leaves us with a ground kind of floating around. And if this was a sub panel, right now these bus bars are connected. So on a sub panel, that should not be the case. So I'm guessing you would break that bond maybe somewhere in here so that you could run this as neutral, run this as ground, remove the bolt, and the sub panel would be complete, assuming you could connect this somewhere over here, which you really can't. Also, there's no accommodations to add any other bus bars. So yeah, this one is a little bit odd, but at the end of the day, these are connected currently, and we want to have the neutrals and the grounds connected in the setup that we're doing here. So this is correct. We do want that screw there, and the ground wire, I think, can connect anywhere, on the box or on the bus bar. But since we have nowhere on the bus bar to connect it, I'm going to use this existing bolt right here and an eyelet to connect ground. And there will be a path from that ground to the box, to that bolt, to the bus bar. So if a live wire shorts out, there will be a path for current to flow, and that'll trip the breaker. And to run this up to the gauge, we're going to connect these wires with the Wago connector. And most likely I'm going to use twisted pair wire, potentially Ethernet. You know, this is low voltage and subject to interference. So the twisted pair on the Ethernet should help minimize that. And ideally, you'd probably even run shielded twisted pair, but I don't have that, so we'll try what we have, and if it ends up being an issue, we can always swap it out. And I've already got a piece of Ethernet here run in. I'm going to cut off the extra wires we don't need. We only need one pair in this case. And the wire gauge should be adequate for what we're doing here. I mean, this pretty much is the same thing. So we're going to strip this back a little bit, get it installed in the Wago, and then I think we can get this cover on. Yeah, holds it pretty well. I was a little worried that the gauge might be too small. But that is not the case. And with that, we are theoretically done, so hopefully we don't need to pull the cover to troubleshoot any issues. It went together quite well, and everything is nice and tidy. I also zip tied these wires together, ran them up to the top of the cart. These are the wires we're going to use for the meter. And I also added a hook to hold the main leads from dragging on the ground, both for the load bank and the ones feeding the breaker panel. So the ferrules have been added. And I would say for the most part, we should be done back here. So let's turn our attention to the meter, get that wired up, and then I think we'll be ready for a test. Well, I think I just jinxed myself because as soon as I said, I hope I don't have to go back in there, I took a look at the gauges that we're going to install, and both of them still have their current transformers. So the transformer I installed was actually from a different gauge. And although it will send some kind of reading to these gauges, it's not going to be calibrated correct. And really, the correct way to fix this would be to swap that current transformer out. Now, the only downside is that the transformer on these gauges, the inner diameter is smaller, and you cannot fit 4 gauge wires through it, at least not 2 of them. So we're going to have to abandon the idea of putting one of these on the load bank and instead put one current transformer on each leg, and we'll monitor the legs individually going through that breaker panel. So I'm not going to record it, but just know I am swapping that out, and we're changing the plan up just a bit. And this is kind of the end result, or at least close to it. I still need to tidy up, but we have both current transformers installed, connected with Wago connectors to the Ethernet, using the blue and the green twisted pair. And I also added another 2 amp fuse. So we're sending both legs of power up, one for each meter. All right, we're in the home stretch. So what I need to do first here is split the neutral wire from 1 lead to 2. So we're going to use this Wago connector to do that. We're going to need 1 neutral for each meter. like that. And the last piece of the puzzle, this is a part my son designed and 3D printed to hold the meters in place. So all we need to do is make a few connections, and we should be ready at least to try a test. And it is finally the moment of truth. So there is quite a bit of time and money invested in this. And as of right now, everything's perfect. And I'm hoping it stays that way once I energize it. So for the initial test, we are going to be using utility power. I've got it wired into the utility. Power's off right now, and this connection only has access to 30 amps. So we're going to be limited to about 7,000 watts max. But even with that, we can test all the loads individually, make sure everything works well together as a system. And if it does, then we should have the green light for trying this on something larger. All right. Here goes nothing. No loud noises. So far, so good. Well, so far, so good. No flashes of light, no loud noises, and no smell of electrical fire. And everything seems to have powered up. The load bank is online showing 250 volts, 60 hertz. The new gauges are on, and they're recording the voltages of leg 1 and leg 2. The amp probe, no issues measuring the THD at 2.5%. And the oscilloscope also working well and plugged in to the outlet here on the front, which also has these testers which indicate the wiring is correct. So let's check the kilowatt, which is also plugged into the front here. We're at 124.3 and 60 hertz. So that is perfect. So let's try putting on a load. We'll start with 3,000 watts on this new space heater. And with the way the gauges are wired, we should see half the load on each leg. It should be a balanced load. And we do. On leg 1, we have 1,536 watts. Leg 2, 1,540. So they are closely matched. And technically a little bit over the 3,000 claim on the front. Let's do the same over here. We should double the load. So total load is now 6,000 watts. And we should be pulling about 3,000 from each leg. And we are 3,065, 3,071. So let's take the load off this one. And we're going to bump the load up here on the right to 5,000 watts. And if that's working properly, we should see about 2,500 watts on each leg. And we do. 2,524, 2,536. So that is perfect. It's also showing the amps, just over 20 amps, actually close to 21. And the frequency dropped a little bit, according to these, to 59.9. So good. Space heaters check out. Let's try the load bank. We did plug it in to the breaker panel, so we want to make sure that that is still working properly. So we're going to start with the fan control. The fans only run off one leg, so this is an unbalanced load. And I was estimating it takes about 200 watts, but with this, we can see exactly now how much it takes. And not as much as I thought. It surged to about 122, but the running wattage, only about 75 watts, 0.6 amps. So not quite as much as I thought. Let's bring on a 4,000 watt load. And it is reading correctly, about 2,000 watts on each leg. A little bit over, actually, probably closer to 2,100 on each leg. Let's go up to 6,000. And we're showing 3,000 on each leg. How about 7,000? And yeah, I'm pretty happy with these meters. They seem to be fairly accurate. 3,500, 3,500. And that's what we should be pulling on each leg. And I guess technically leg 1 is overstated because of the cooling fans, which makes sense. So yeah, I'm pretty happy with this. Everything's working well. So I'm going to let this cool down a bit. And I'm thinking we should try the portable space heaters on this outlet. Maybe plug 2 of them in and just make sure that everything's good there and that the meters can report the load correctly. And yes, my confidence level, it was high, but just in case, the way I wired this, I would not say is approved, but it's what I had to do for the sake of science. So shut the fans off and plug in some heaters here, which technically, we could add another 4,000 watts here. So this entire cart is technically capable of about 24,000 watts. Now, the only thing I don't like too much about this are these plugs. These have the shutters on them that prevent foreign objects from going in, but they also prevent the plugs from going in without using excessive force. So that might be something to swap out at some point. So now that we're in, we'll put on one load, 120 volts. It's going to pull from one leg only, which is the top one right here. So a little bit less than the advertised 1,500. It's actually closer to 1,400. And let's try this other one here. 1,500 watts according to the label. And according to the meter, actually a little bit over, 1,560. So yeah, I am pretty happy with this setup. So with these 3 loads here, we can now do 20,000 watts. And technically, with that outlet down there, we can add on another 4,000, bringing us up to 24 kilowatts. So that should be pretty good, I would think, for most machines that I test. So let's take these loads off and power things down. All right, guys, and I think that is it for today. This I'm pretty happy with. Everything seems to work individually. Of course, I'd like to bring on 20,000 watts of load at one time. And to do that, I need a 20 kilowatt machine, which I'm actually working on right now. So that should be done in the next week or two. And when it is, we can test this setup to its full capability. But that said, Even if this is capable and the generator is capable, we do still have one pretty big limitation, and that is the propane setup. Currently I am running off of 2 grill propane tanks, and pressure is an issue. The regulators I'm using theoretically can go up to about 22 to maybe 24 kilowatts, assuming no pressure drop. But the T that connects the regulators into the generator, that is a bottleneck. So I'm going to make one small change and swap out the T for this one right here, because the current T has these small flare fittings, both on the input sides as well as the output. And this one has a flare that is twice the size. So that's going to allow more volume of gas. And I'm hoping that this small change will allow the current setup to achieve 20 kilowatts. I guess we'll find out in a couple weeks. So I hope this video helps someone. Thanks for watching.